All right, Wiley, question number 11. Again, so it's structure elucidation, right? They want us to select the structure. And they give us the formula, which is C4H9Cl. They give us the protein, the hydrogen protein NMR data. It's a doublet. There's a doublet at chemical shift 1.04, and it's 6 hydrogens. There's a multiplet at chemical shift 1.95, and it's 1 hydrogen. And then there's a doublet, and the chemical shift is 3.35, and it's 2 hydrogens. So from this information, we can tell that there's 2 hydrogens that are very close to the chlorine atom because they have a large chemical shift, which means they're downfield. There's 1 hydrogen. Well, these 6 hydrogens here are farthest away from the chlorine because they have the lowest chemical shift. That means they're the most upfield. They're a doublet, which means they're next to only 1 heterotopic hydrogen, 1 hydrogen that's in a different environment than they are. This 1 hydrogen is somewhere in between these 2 hydrogens and these 6 hydrogens, and it's a multiplet, which means that it's probably next to, like, if it was in between these 6 hydrogens and these 2 hydrogens, like each one of these peaks could be divided into 3. So, well, that's something. They're not asking that question right now, so I won't get too deep into it, but it's just a multiplet, meaning that it's next to 2 different kinds of hydrogens. It's not next to just like 6 homotopic hydrogens. It's next to these 6 homotopic hydrogens and these 2 hydrogens, which are different than these 6 ones. So its peak is being split many times. It's being split 7 times here, and then all of those 7 could be split 3 times, so it could have 21, or it could be 7 and 3, which would be 10, or there's different ways it could be split. Anyway, it's just being split by a lot. So the structure that makes sense is CH3 right, so these 2 hydrogens right here are closest to the chlorine atom. They're downfield, and they're split only into a doublet because they're 3 bonds away from this 1 heterotopic hydrogen. This 1 heterotopic hydrogen is right here, the 1H. It's a little further upfield. It's further away from the chlorine, the electronegative chlorine. It's split into a multiplet because of these 6 heterotopic hydrogens here, and then the 2 here. It's in between, 2 different kinds of hydrogens, and it's splitting up its signal into several different peaks. So that's where the multiplet comes from. And then these 6 hydrogens are the furthest away from the chlorine. That's why they're the most upfield, and they're split into a doublet because they are 3 bonds away from only 1 heterotopic hydrogen. So that's it.